Alright, gonna be a quick video on the air, the latest toy. Well, not on the air, on the dummy load. This Alpha 76A, but basically it's a 3-tuber. And I think the 3-tuber is either a PA or CA, with the PA having the regular transformer and the CA having the bigger hypersteel transformer. And I think this one is a CA, but not 100% sure about that. This one has 10 meters in it from the factory. Some of the later ones had the band switch where they blocked out the 10 meters back when the FCC cracked down. So it only went through 1.8, that's actually megahertz, to 1.8 to 21 megahertz. And the 28 megahertz 10 meter band was blocked out. But this one has the factory 10 meters, normal tune and load, on switch, off switch. It's got a plate current meter there, full-time plate current, and a multimeter over here. And the multimeter, depending on the switch, you can measure high voltage, which is on now. It's running about 2300 volts. You can measure grid current, forward power, and reflected power. And then over here, CW SSB. Basically, SSB is high voltage or high side, and CW, it has a separate tap on the high voltage transformer, a lower tap. So it'd be the low side if you go to CW, if you want to look at it that way. So we got it all tuned up, hopefully, on SSB, the high side, and we run it off a foot switch underneath, and we got the JB-200, aka JB-76, two 8417 tubes going into it, and we're gonna put it on the 200 watt scale on average. And this is just the JB-76 going into a dummy load. Audio. So we're doing about 100 whistle. We're talking about 50, maybe 60 on the JB-76. A lot of swing, very little dead key. Dead key in about 5 watts. So anyway, we're gonna go to the 2000 watt scale, and we're gonna hit the foot switch now. Lights light up red. You can see the resting plate current, and the high voltage dips a little bit when you key it down. You're basically putting the ground on the tube, and that's basically conduction of the tube right there with no drive. I had a discussion with somebody, it might have been here on YouTube, where somebody said, you know, you oversize the capacitors, that it's going to be drawing, you know, current and stressing the transformer all the time. And I said, no, it ain't. It's the tube that is the load for these things, and it's the tube that's going to draw the current. You can put, you know, great big capacitors in this thing. You know, some low voltage power supplies have, you know, 10,000 UFs, or, you know, stereo amps that have 50,000 UFs. You know, they're not stressing the transformer. All it does is regulate the power better. Just like here, you know, the high voltage is applied, but the tube is not conducting. There's no load on it, so the amps are at 0. You know, no matter what size capacitors I put in this thing, or, you know, in another amp. So you could up the capacitors. It's just, you know, other things you got to worry about, like turn on surge. But this, you know, bigger amps like this, and, you know, well built amps, it's got step start. So it's got a resistor in line that lowers the voltage of the current until the capacitors get charged up a little bit, and then it switches in a relay after a couple seconds that applies full power to the transformer, and then hence full power output, you know, to the capacitors. And even just, you know, keying down with that little bit of conduction, not driving it, you can see the voltage drop a little bit. The more capacitors you put in there, the less voltage drop you would get. So it does raise the the load voltage a little bit. But resting, you're going to have the same thing because it's not pulling anything off the capacitors. It's not sucking anything down. So one of the advantage, or the main advantage of adding more capacitors in it, you won't get this voltage drop. And actually I'm going to leave it keyed with the foot switch. And now I'm going to key the radio and the driver and put drive in it, and just to show. You see that voltage drop there? Audio. See the voltage meter dropping with the audio as I speak? The more capacitance you have, the less of that you would get, less voltage drop. So that's the advantage of having it. And that voltage drop is not a good thing. You know, as your modulation's going up, that voltage is going down a little bit. So that's making you a little bit non-linear. So more capacitance would make it a little bit more linear. So that's my thoughts on that. And hello audio. We're whistling to about 1200 audio. We're only talking about 6 on average. And last we're just gonna put it on peak. Let me key the foot switch first. With an amp with the foot switch like this, you key the foot switch first, and then you key the radio. That takes some getting used to if you've never done it before. Audio, and just maybe talking to about 2000 peak. Audio, right near it, and might even be hitting it. Audio, and that's the most I can get out of it, is 2000 peak. I think the 8874s, if they're a little bit fresher, I can get a little bit more out of it. That's the plate current, so I'm not hitting it that hard either. And you can see the voltage drop. And let me see if I can put it on grid. Audio, that's the grid current, so I'm not hitting it too hard, not stressed out too bad. So that's the Alpha 76 3-tuber. You know, very clean. My latest toy with the I think the Hyperseal transformer and the 3 tubes. We'll show the inside in the next video, I guess, unpowered. Alright, that's it for this one. Hey, it's an Alpha. I think I could put a brick on it and do that all day. Alright, bye.